Alright, today's problem's name is some root to leaf numbers and it's a tree problem. So let us see what the problem states. Given a binary tree containing digits from 0 to 9, each root to leaf path could represent a number, and we have to find the total sum of all root to leaf numbers. So pretty easy to understand. Leaf node is a node with no children, the terminal node you can say. So let us see the example. Suppose the given binary tree is in this form 1 2 3, so you can see that there are two leaf nodes 2 and 3. So you need to find two numbers, add them together, and that will be our answer. So 1 and 2, that is 12. The root to leaf path 1 2 represents the number 12, and the root to leaf, this root to leaf path represents the number 13. So you add 12 plus 13, that is 25. And in the next you can see that this is our tree. So one observation you can make from here, that you can know exactly how many numbers you are adding by looking at how many terminal nodes it has. So this has 3 leaf nodes or 3 terminal nodes, so you can see that there are 3 paths and you are adding 3 numbers. So it was pretty basic. For solving this problem, I will be explaining recursive function, and I will be explaining how you can traverse the tree in a depth first search manner using recursion. And now I'll be writing the recursive function which will do this work. So many things to learn in here. First of all, the return type will be void, and what I will be calling it, let's say count sum, because it will eventually give us a sum. And what two parameters it will take, one will be the root, okay, of course, for traversing through the tree, and the other one I'll take a string, let's say string, I'll name it as current sum, because it will reflect that only, our current sum. And here I'll be writing the code. Okay, so I'm writing it against the picture so it becomes better for you to understand. So first of all, the exit condition, you must always start thinking from the exit condition. So the exit condition will be if suppose our root is null. So this is a very common exit condition and it's the first thing that comes in the mind. If suppose root is null, then we can simply return, because it's a void function, so I can write simply return. Okay, now we have to think that how we can traverse this tree recursively, and this is the most important part. You can write 2 recursive calls. Let me write them and I'll explain what they are doing. I'll be counting this function once from root.left by giving it the left child of the current node, and my current sum will be as it is. And the second one just below it, I will be calling it again with passing the right subchild, and my current sum will be as it is. So what these 2 calls will do, let me tell you how we will be traversing this tree. Okay, so first we are at 4. Now our root is not null, so we'll go down, and I have called this function with root.left, so we're gonna go here. Now again 9 is not null, and we go down here. Now again we are calling it left. Okay, so we'll go here. Now 5, as you can see that there the left subchild of 5 and right subchild of 5 both are null. So we have to make another condition, because whenever we are here, what we have to do, we have to include it in our sum. So what I have to write here, first of all I have to count 4, 9 and 5. So for every call what I will do is, so my current sum, it will be equal to current sum plus root.val. I am basically adding every number that every value of node that we are going across. And now I have to add another condition, that suppose if the current nodes left and right subchild are null, so if root dot left is equals to null, and root dot right is equals to null. Now this condition reflects that we have encountered a terminal node or a leaf node. Then what we can do is answer is equals to answer plus current sum. And don't worry, I will be using a parse int function that will convert this string into an integer, but this was just a logic part. And for answer you can take a global variable answer, which will automatically get updated every time. So this function should really do the work. And how it is performing, see here, first we were at 4, then we went to 9, then we went to 5. Now 5 is a terminal node. Now as soon as 5 is our terminal node and our current sum till here was 495. Now I have encountered that yes, 5 was terminal node, so I will add it simply in our answer. So our answer will be 495 currently. Now how this is the logical part, that how this 5 is going off and we are getting retraced back to 9. This is because we are not removing 5, but we are automatically getting retraced back to the previous calls. So previous calls when our current didn't include 5. So earlier our current was like this. So we are not removing 5, actually we are getting retraced back earlier when there was no 5. But as once we have gone here, now there is no need of going to the left again. So now we will go to the right. So now 1 will be added here, and also 1 is a terminal node, so I will add this current in my answer. So answer will be this plus 491. Now since I have explored both the left and right subchilds of our current node, so what I will be automatically retraced back to the previous calls where there was not 1, there was not even 9. Our current earlier was this. Now I will go it in the right subtree and 0 will be added, and 0 is also a leaf node, so I will add this in my answer, and the answer comes out to be 1026. Okay, so this was the code, and this is how this code is gonna perform. These two lines basically helps us in traversing through the tree in a depth first search manner. So I hope that things are clear now. So we have to just code this only. Let's see this. First of all, we have to take a global variable integer answer, that will be our answer. Okay, now inside coming of this, I will first check if suppose the given root is null, then our answer should be 0, of course, and if not, then we have to write a helper function, that is count sum. We have to pass root and an empty string first. Okay, and after calling this function, what we have to simply return is our global variable that will contain the answer. Alright, so till here we are okay. Now we have to write our helper function, that is void count sum, and what it must contain is node root and a string that is called our current sum. Okay, now the helper function will be there. So what we have to check, first of all, our exit condition. So if suppose root is null, then simply return. Okay, now what next was there, we were adding the current node in our current sum. Okay, current node's value, sorry. So current sum will be current sum plus the root dot val. Okay, after this we have to check for the terminal node. So if our node, if its left subchild is null and its right subchild is also null, then that simply means that it's a leaf node, so it's time for us to update our answer. So answer will be, I'm going to convert the string into an integer in order to store it in an integer variable, and that will be current sum. So Yeah, this was it. And the two super important calls for traversing the tree recursively, that is calling it by passing the left and the right subchilds. So root dot left comma current sum and root dot right current sum. Yep, I guess this was it, and included everything. I hope so. Let's run this. Let's see whether it works. Yep, expected answer is same. Let's submit it. Okay, accepted. Hope that now you'll be able to traverse the tree recursively, and I hope that you have built that logic in mind.